Hey everybody, it's Norm from Testin, and welcome back to Projections, where this week we're going to be talking about the intersection between virtual reality worlds and the real world, or mixed reality. One of the challenges of VR right now is communicating the experience to you out there, the viewers. You can capture what the person in the headset sees using capture tools, whether it's on desktop or mobile, but the most effective way of showing people what VR is all about, aside from actually putting them in a headset, is with mixed reality recording. Back in the day, when the first HTC Vive came out, there were camera rigs are set up with HTC trackers, so the camera would be tracked in a virtual space, and custom software would have to be written to then show a mix of the virtual space and the person using the VR game in that space as well. And those tools are actually now accessible to you out there, to VR users. A company called Live, and they have a free software tool on Steam that you can try right now. And if you have like a GoPro camera and a green screen and you want to see yourself in Beat Saber, it's not that difficult to have it all set up and to put yourself in that space. That's what we wanted to try today. So we invited one of the engineers from Live, David, over to our studio, set up a big green screen backdrop, a bunch of lights, and put me in Beat Saber. Here's a little bit of me in Beat Saber, and also a conversation with David about the engineering, what goes into that tech, and what they are going to do going forward. Let's take a listen. David, thank you so much for coming here and setting up. How are you doing?
Good, how are you?
Doing really well, having a lot of fun, probably the most fun I've had in Beat Saber in a long time, because it's like being in one of those commercials that they put out. Because I'm in mixed reality. People have seen these videos on Facebook and on YouTube, and it's a problem in VR in general, like showing the experience.
Absolutely,
right? That's
yeah.
the whole point of what Live does, is to help with that. So can you give me like a little bit of a history of Live and where mixed reality came from back when people were trying to do it with the original Vive headsets?
Sure. So Live was started a few years ago. Originally, our first product was just this folding sort of green screen cube, because we have a green screen right behind us here, but it can be difficult to set up a nice green screen like this with all the lighting and everything. So it was called the Live Cube. It was just a bunch of lights and stuff. Ended up not working out so great for us to manufacture, so now we're just focused on software. You can't see it on the computer here right now, but we have our own software called the Live app. And the Live app composites mixed reality for you and handles calibration and all that sort of stuff. So you have sort of a holistic mixed reality creation tool.
I mean, to try to explain the problem or the challenge of mixed reality, when I put on a headset, any VR headset, you can see what the person's seeing, and that's your fixed camera view, which isn't necessarily what people out there want to see. It's like it works, right? It can communicate that experience, but you really want the person to be in the camera frame. And so you need a virtual camera.
Exactly.
And some applications will let you put a virtual camera that you can then put on your computer screen and record that, but that doesn't show the real you either. It's not mixed. So what we're filming with right now is just a standard camera, right? People have used
GoPros,
Kinects,
DSLRs. DSLRs.
Exactly. That
red
feeds,
cameras.
Oh, even red cameras on the very, very high end. You're feeding basically that HDMI output, but then how does the virtual space and the game or whatever experience know where that real camera is relative to you in the world?
Yeah, so the Live setup starts with a calibration process, and what we do there is we sort of have a magic triangle where you take one of your controllers. First, what you do is touch the camera lens, so it knows where the camera lens or the camera sensor is. Then you touch one corner in the top and one in the bottom right corner. And from that, it can figure out the field of view, the position and the rotation of the camera. And with that information, we can tell the game, put a virtual camera inside the game at this exact same position, this exact same orientation, and use this exact same field of view. And then once you do that, you'll see that your virtual objects will line up with the real world. So I have this virtual lightsaber attached to my hand here. And then what we do from there is we have a foreground and a background camera, and what that will let us do is objects that are behind us will be occluded. You probably can't see it because of the tracking right now. And objects in front of us will stay in front of us.
And that calibration that you did, that we've done here, that takes the place of needing then a dedicated tracker on the camera.
Well, you still do need to calibrate if you're using a dedicated tracker. The dedicated tracker just gives you the ability to move the camera around while you're recording.
Right, right. So when you have like those HTC Vive pucks,
Exactly.
those are mounted and rigged up to a camera, but that's not exactly where like the camera sensor is. It doesn't take into account the focal lengths and field of view. And by this triangulation, because the geometry in the game is always going to be that triangle.
Yes.
It actually does the math for all that kind of distortion.
Yeah, so what we're doing when you're calibrating, if you're not using a tracker, we just figure out where the camera is relative to your VR space. So that might be your tracking origin on a Rift, a Vive. Rift S could be, you know, your real world with inside-out tracking. Or if you do have a physical tracker attached to the camera, we just figure out the offset between the camera sensor and that tracker.
And then you can tweak the latency, you can tweak the offset, things that just have everything match up perfectly, because you're going to get frames misaligned here and there from the HDMI or from however you're capturing it.
Yeah, so all cameras have some sort of latency, and usually the game is rendering faster than the amount of time it takes for the camera to send a frame to the computer. So what we do is we let you delay the game so it aligns perfectly with the camera feed.
And not just like in the frames, right? Frames and sub-seconds, so you can still play Beat Saber and play it comfortably.
Yeah, it has no effect on the actual gameplay.
Oh, right, right, okay. So you said the game is generating more views, right? A virtual camera. Beat Saber out of the box does that because they've worked with your SDKs.
Yes.
So game developers and software developers creating VR experiences want to tap into that so that they can automatically generate those views.
Yeah, so we have our very own Live SDK, and what developers can do is just drop that into their Unity project or Unreal project. It's super easy. We're working on a tutorial video right now, and what I like to say is it takes literally 2 minutes, because our tutorial video is only 2 minutes long. And once that's in your game, you can just add, or you can go to the Live app here, and your game will show up in the Live app. You can capture it, and it just sort of works magically.
That's really cool. You mentioned occlusion as well. It's something that really blew our mind, because while you can superimpose our video image in, we see right now, there's the Beat Saber menu behind us. When you're playing the game, as we saw these video clips made by Liv, the box moved behind you and actually occlude over you.
Yes.
And how does that work? How does the game know where the blocks are relative to you? And how does that seamlessly, like right now, this lightsaber is cutting through me.
Yep.
And then disappearing or in front of me. Like its occlusion is working right now.
Yeah. So it's surprisingly simple. What we're doing first of all is just using the green screen or a Kinect or whatever method of background removal you're using to segment your body from the rest of the feed that the camera sees. And from that, we just have your body, and we put the game right behind it. But if you just have the game behind it, you'll see that objects won't go in front of your body like they are right now.
Yeah.
So then what we do is we take everything that's between the camera and the headset and consider that the foreground. So there's a separate, the game's actually rendering two cameras. One's the background, and that's everything behind us. One's the foreground, so that's everything between the headset and the camera, and everything between the headset and the camera will go in front of our bodies.
Of course, and then the position of your head, that's what generates that plane.
Exactly, yeah. So it's just this big clipping plane.
And it's relative to the camera, and so it's not rotating at all. It really is just that, and it can move as, and updates in real time.
Yep.
That is so cool. I mean, it's so much thought. I mean, it's a lot of engineering work to get that to work.
It's surprisingly simple, but we are working on more advanced ways of making that work. One of the things you might notice, it's very hard to actually make it happen in real world scenarios. But for example, my arm maybe should be occluded here, but it's not.
Right, right.
So in the future, we'll be doing stuff like using IK to generate that plane, or if you have a depth camera like a Kinect, using the depth information to do better occlusion. That's always going to be spot on.
Right, so either it's computer vision and you're using separate, like, more info with the depth camera, or IK, because then you're feeding more positional information.
Exactly, with some knowledge about where the body might be instead of just this flat plane.
Yeah.
But it works surprisingly well.
Yeah, it totally works well. Something we really experiment with, I know you guys aren't making it public, is also the ability to move the camera, or at least seemingly move the camera with rotation. This, again, blew our mind, because it gave the illusion that the camera was actually flying around, although it's not, because it's not being, the tracking of the camera isn't being updated in real time. How does that work? So
this is something that's still kind of experimental with us. For us, it's not something that we have any plans to release yet, but if there's a lot of demand for it, we'll definitely think about it more. Basically what we're doing with a headset like the Rift S, it's using inside-out tracking. You can't use something like a Vive tracking puck to just stick on the camera. Although maybe you could use some sort of external tracking system, and we have more to do with that in the future. So what we're doing here is we're just rotating the virtual world. And the player just has to sort of spin around while they're playing whatever game they're playing.
Yeah.
And it looks surprisingly realistic, as if the camera is sort of doing this big orbit around them. And you can even do stuff that would be nearly impossible to do without some crazy expensive camera track or something like that.
Right.
And it looks fantastic, as you can see in some of the footage.
So as long as the user, the player can be comfortable with that rotating world, because the actual game world is physically rotating,
yes,
and the camera is offset from the player.
Camera's always in the exact same spot. Right.
Oh, it's really trippy, the mental gymnastics, but again, the illusion is totally convincing.
It really is.
Yeah. You're tapping into the Steam VR compositor, is what makes a lot of like the in-headset stuff work.
Yeah.
Is there more plans to, because in headset right now, something I can see is I can see basically a window with what this composite looks like, right?
Right. So while you're in the headset, maybe you're live streaming or something, and you don't have another person helping you and making sure the framing is good and all that. What we do have is there's this little overlay that pops up in the headset, and right on the camera, you can look at your camera, and where the camera is in real life, you'll see a viewfinder as if the camera screen was facing you, except it's actually in your headset.
And that's what you're also using for the calibration as well, the superimpose and overlay?
Exactly. So you don't have to close your game and all of that. We have an overlay in the headset that you can use for calibration, and then you just do your 3 taps. It's just like that, and we're working on bringing more and more of our UI into VR with that.
That's what I was going to ask, because presumably this is made for live streamers and people who want to be in VR and share that experience, so you may want other UI elements to help tweak or add effects or have input from the outside world.
We definitely want as much as possible controllable from it within the headset, because when you're a one-person streamer or a one-person YouTuber, it does get pretty tedious going back and forth between the computer.
Yeah, Live is it's released now. People can find it on Steam. You have users who
free download,
and people are setting up their own green screens. Any kind of tips? Because like we have studio setup here. There are actually 8 lights we have set up for even lighting. You don't make that all-in-one cube box anymore, but what can people do to make that, the composite look as good as possible?
Yeah, so we're working on a wide variety of ways that you can set up Live. In the past, it's just been using a green screen like this, and what we have here with all this lighting and everything is definitely a very high-end setup. But we don't want that to be the only option, and it's not the only option. So if you just have a small green screen and less lighting, you'll still be fine. Of course, lighting is always great with any green screen situation, but we're working on stuff other than a green screen as well. For a few months now, we've supported using a Kinect camera to remove the background instead of a green screen. This right here is the Azure Kinect. We also support the Xbox One Kinect, which is a great option because you can get them for around $40 to $50 used usually. And you just plug that in and it just sort of works magically, no green screen. Don't need any crazy lighting.
Do you even need another camera, or does that become...
just uses the camera built into the Kinect.
So it does the depth information, it kind of does all the masking in hardware, and then the capture is what you see.
Yep.
That's really neat. Wow, that's incredible. What about developer relations and support? I mean, we saw this technology that you guys have put out at events. We've seen companies like Beat Saber use it. What's legacy support like for people who've already kind of built in mixed reality solutions using the Vive tracker buck method? And going forward, what's the plan?
Yeah, so we definitely want as many developers as possible using our own SDK because that gives you the best mixed reality output using the Live app. But we do support older games that are just using the Steam VR plugins built-in mixed reality support. More and more developers are moving over to our SDK now. We have great relationships with all sorts of developers, and more developers are coming to us asking to integrate our SDK. But for older games that don't use that, we definitely support them. It's just not quite as polished of an experience.
Yeah, that's awesome. Thank you so much for bringing this and setting up in our studio. I think not only does it enhance the experience for the person in the headset, be able to view it afterward, but like just for spectators. It's just so much fun for people in the room to look at the laptop or have it then broadcast to a TV to see what that virtual world looks like. David, it's a pleasure to meet you.
Pleasure meeting you.
So that was really awesome. Going through that whole process and having David here to help us with the calibration really helped me understand much better how these systems work. And they're using a bunch of really awesome tricks to basically compensate for the fact that the virtual worlds have no idea where the camera is in the real world and how those things are correlated. It's really cool to see that you just put on using any VR headset in Steam VR and the Live program. You can calibrate just by matching those 3 points, and then things like adjusting, compensating for the latency differences, and even kind of faking camera moves. That was super, super cool, and the resulting footage, as you could see, just looks so compelling. Really fun to watch and share. Now, they also have a bunch of other technologies they've built into that Live software. If you don't want to put yourself, your real body in VR, you could then actually use their avatar system, and that then creates basically an IK model of your body and superimposes that over your body. So you don't see you in VR, you see a virtual avatar. That's pretty neat. And then of course, that rigging system, the IK system, will then allow them in the future, as David said, to have even more effective ways for occlusion. So you can actually move body parts over each other. You can have virtual objects you can interact with more intimately, not just swinging those Beat Saber blades around. We also got to see a test of their Kinect system, which is really rad. It works right out of the box with the old school Kinect for the Xbox One, or if you want to buy the latest version for $400. It's totally worth it because you don't need a green screen. I was really pleasantly surprised by the image quality of the Kinect output. One of the really cool things that David showed us is that with the Kinect implementation, you can actually show the Beat Saber blades in front of you looking at camera, but the real world behind you. That was maybe my favorite use of this. And in fact, if developers want to use Unity and create experiences that may not be even game related, it doesn't need to be Beat Saber, but create some type of virtual environment, because you can do that occlusion, you can render those views in front of the user, you can basically create your own kind of holographic interface. If you're making some kind of short film, you can do that kind of special effect in real time with the performer in headset or not, and have it work right out of the box. There's a lot of potential for this mixed reality for filmmaking purposes. And looking to the future, they've already announced not only integration with the mixed reality Oculus SDK that will be coming out and all the games that will support that, but also an implementation with iOS. So you could actually use your phone or a tablet that has ARKit and use that as the camera with the Live software and all the games that will support that. I think mixed reality kind of filmmaking is really going to be important for sharing VR in the future and growing the VR community. I want to see more developers adopt that Live SDK because I want to see myself in more experiences and more games. And it's going to be, I think, another powerful tool for filmmakers and cinematographers working in real time, doing some cool effects compositing. We'll be back in the future with more cool technologies in the VR space to talk about. Thank you so much for watching, and I'll see you next time.